All right, so we're going to go over Chapter 6, Lesson 5, solving open sentences involving absolute value. So we're going to learn how to solve absolute value equations, and we're going to learn how to solve absolute value inequalities. How is absolute value used in election polls? So it says, voters in Hamilton will vote on a new tax levy in the new election. A poll conducted before the election found that 47% of voters surveyed were for the tax levy, 45% were against the tax levy, and 8% were undecided. The poll has a 3-point margin of error. So here's a graph of that data there. It says the margin of error means that the result may be 3 percentage points higher or lower. So the number of people in favor of the tax levy may be as high as 50% or as low as 44%. This can be written as an inequality using absolute value. So x minus 47, its absolute value is less than or equal to 3, because we know that the survey said that it was approximately 47%, but there's a margin of error of 3%, so it obviously could be 3% higher or 3% lower, right? So whatever the real value is, minus 47, which is what we got, the difference in the absolute value, and if you remember, absolute value is its distance away from 0. That's what absolute value means, right? So the absolute value of something is how far is that value from 0. So obviously the difference, whether it's positive or negative, is going to be less than or equal to 3. Absolute value equations. There are 3 types of open sentences that can involve absolute values. There is absolute value equal, right, an equation. Absolute value involving a less than symbol, right, in an inequality. And absolute value that's greater than involving a inequality, right? And obviously you can have less than or equal to or greater than or equal to as well. So if you consider the case that the absolute value of x is equal to n, let's say that absolute value equals 5 means that the distance between 0 and x is 5 units. So something like this, right? So if the absolute value of x is equal to 5, that means the distance from 0 is 5 units. So that means x could be negative 5 or it could be positive 5, right? Because both of those numbers have a distance of 5 units from 0, right? That's what absolute value means. Absolute value refers to a distance. Distances we don't refer to as positive or negative, right? So either one of these values would have a distance of 5. So if the absolute value of x equals 5, then x can equal negative 5 or it can equal positive 5. So the solution set for this equation would be, the answer would be negative 5 and 5. This is the solution set, right? Both of those values are part of the answer. When solving equations that involve absolute value, there are 2 cases to consider, right? Case 1 is that the value inside the absolute value is positive, right? Like here we assume that it can equal the positive value. And case 2 is that the value inside of the absolute value can be negative. Equations involving absolute value can be solved by graphing them on a number line or by writing them as a compound sentence and solving it. So let's take a look at an example. Solve an absolute value equation. Solve the absolute value of a minus 4 equal to 3. So let's try a method where we use a graph. So a minus 4, absolute value of that, equals 3 means that the distance between a and 4 is 3 units. To find a on the number line, start at 4 and move 3 units in either direction, right? So we start at positive 4 and if we move 3 units in both directions, that would put us at 1 and at 7, right? So the distance from 4 to 1 is 3 units, and the distance from 4 to 7 is also 3 units. So here, the answer to this problem, right, the solution set would be positive 1 and positive 7. And that would be our answer there. So that would be a method using graphing. Let's use a method using a compound sentence. So this is method 2. So here I'm going to write the absolute value of a minus 4 equals 3, right? So I'm going to write it as the inside, right? A minus 4 equaling the positive value, 3. And I'm also going to write a minus 4 equaling the negative value, negative 3, right? Because the absolute value can be equal to the positive and the negative value of that, right? Because both of those will have that same distance of 3. So a minus 4 equals 3. I can go ahead and a minus 4 equals negative 3. I can go ahead and solve that as well. So these would be my two equations that I want to solve, right? One where the value inside of the absolute value symbols is equal to positive, absolute value equal to the negative, right? So let's go ahead and solve case 1, right? Add 4 to both sides. That would give me a equals 7. Here again, add 4 to both sides, and I'd get a equals 1. So again, I get to the same answer whether I solve the two equations that I get from the compound sentence, right? Or whether I use the graphing method. But the solution set is the same. The solution set is at 1 and 7. Let's look at example 2. It says write an absolute value equation. So here they want us to write an equation involving absolute value for the graph. And so here's a number line. And if you notice on the graph, I see two solid dots, which means it's currently graphing the number 3 and the number 9. So it wants me to write an absolute value equation, right? So if I find the point that is the same distance from 3 and as the distance is from 9, the midpoint between 3 and 9 is 6, right? So if I look at 3 and 9, I know the distance is 6. So I know the midpoint is 3 units in each direction towards the middle. So that means that's going to be at 6, right? 3 units this way, 3 units this way. So there's the middle, there's 6. So that means 6 would be equal distance to both of those numbers, right? So the distance from 6 to 3 is 3, and the distance from 6 to 9 is also 3. So my equation is the absolute value of x minus 6 is equal to 3. So basically, it's like the last problem we did, but in the reverse order. Instead of going from an equation to an answer, they give us the answer, and we have to write the equation. So now that we have our equation for this, let's go ahead and check and make sure we're actually right. So what we're going to do is we're going to substitute 3 and 9, right, our answers that were originally given. If I substitute those back into the equation, is it true? Well, let's look. If I take x minus 6, the absolute value of x minus 6 equals 3, let's go ahead and substitute 3 in first, right? What is 3 minus 6? 3 minus 6 is negative 3. And the absolute value of negative 3, right, its distance to 0 is 3. So does 3 equal 3? Yes, it does. It checks out. Now let's try it with the other value, 9, right? That was another one of the original answers that we got. So 9 minus 6, right? 9 minus 6 is 3, and the absolute value of 3, right? What is its distance to 0? It's 3 units. So 3 equals 3. It checks out. So clearly my equation that I wrote works because I know the original answers work. Absolute value inequalities, right? Consider the inequality, the absolute value of x is less than n. So absolute value of x is less than 5 means that the distance from 0 to x is less than 5 units, right? So whatever x is, its distance from 0 has to be less than 5. So now we're going to be looking at this type of problem. So any number between here, between positive 5 and negative 5, is going to work as an answer for this inequality, right? Since it's just less than, it cannot equal negative 5 and it cannot equal positive 5. So it does not include these two values, but everything in the middle, right? If x was 0, is the absolute value of 0 is also 0, which means that 0 is less than 5. What if I put negative 3 in? Negative 3 in for x, right? The absolute value of negative 3 is positive 3, and positive 3 is less than 3, right? So all of these numbers in between here work. So therefore, since x is greater than negative 5 and x is less than positive 5, the solution set, right? Remember how I said that the absolute value, you always set it using the positive version, right? So we keep the inequality the same. And when you set it equal to the negative version, since we're kind of like dividing both sides by a negative, you have to flip the inequality. So that's what my solution set would be, right? X has to be greater than -5 and less than +5, which would be written right there. When solving inequalities in the form of absolute value of x less than n, find the intersection of these two cases, right? In case one, you find you take the value inside the absolute value symbols is less than the positive value of n. In case two, you take the value inside of the absolute value symbols is greater, right? Flip the inequality symbol than the negative value of n, right? So notice how we wrote both of those, one with the normal inequality to less than and the positive, and then we flip the inequality symbol to the greater than and did the negative. So what does that look like in a problem? Let's take a look. So to solve t plus 5, right, absolute value of t plus 5 less than 9, and then graph the solution set. So again, I'm going to rewrite this in both the positive version, right? So t plus 5 inside less than positive 9. And then I'm going to take the inside of the absolute value t plus 5, and I'm going to set it to the negative version. And when I set it to the negative version, I have to flip the direction of the inequality symbol. So now it's going to be greater than -9, right? One case where it's less than +9, and the other case where it's greater than -9, right? Flipping the inequality symbol. So let's go ahead and solve each one. Case one would be the positive version, right? T plus 5 less than 9. Case two would be t plus 5 greater than -9, right? So these are my two cases that I'm solving. So I'm going to subtract 5 from both sides, and it leaves me with t is less than 4. Now let's solve this one. Subtract 5 from both sides, and I get t is greater than -4. So now I have my two inequality symbols, and let's go ahead and look at what that looks like on a graph. So t must be less than 4, right? And greater than -14. So when I look at my number line, it's going to look like this, right? These are all the values where t is greater than -4 and less than +4. Sorry, greater than -14 and less than +4, right? Any value in between here will end up working in this inequality here. So consider the inequality, the absolute value of x is greater than n, where the absolute value of x has to be greater than 5 means that the distance from 0 to x is greater than 5 units. So again, on a number line, this is what it's going to look like, where these numbers that are less than -5 and these values that are greater than +5 will all have a distance, right? Distance greater than 5, right? Distance from 0 greater than 5, right? So therefore, if x is less than -5 or x is greater than 5, the solution would be like this, right? X less than -5 or x greater than +5. So when solving inequalities in the form where you have an absolute value greater than n, you find the union of these two cases, right? So case one, you take the value inside of the absolute value symbols is greater than the positive value of n. Case two, where you take the value inside of the absolute value symbols, and it's going to be less than the negative value of n. Again, remembering that whenever you do the positive and negative version, you flip the inequality symbol, right? The positive version is always matching to the original inequality, and then the negative version is flipped. So let's look at an example. I have the absolute value of 2x plus 8 is greater than or equal to 6. So let's go ahead and solve it. So again, I'm going to take my original inequality symbol, and I'm going to write my two cases. 2x plus 8 is greater than or equal to 6, right? The normal positive version. Or 2x plus 8 is less than or equal to -6, the negative case, right? So here's the positive case. Here's the negative case. So now let's go ahead and solve. So in this one, I'm going to go ahead and subtract 8 from each side. And then that leaves me with 2x is greater than or equal to -2. Divide both sides by 2. And I get x is greater than or equal to -1. Now let's solve case number 2. So again, subtracting 8 from both sides. Then I get 2x is less than or equal to -14. Divide both sides by 2. And I get x is less than or equal to -7. So now I know that my solution set tells me that x has to be less than or equal to -7 or greater than or equal to -1. So what does that look like on a number line? It looks like this, right? My values of x can be less than or equal to -7, or my x values can be greater than or equal to -1. Again, close circles because they can equal. It's inclusive of those two values. So that's how I would do that one. So in summary here, right, the absolute value equations and inequalities, there are three rules to remember when solving equations and inequalities involving absolute value, right? When we have equations, right, you can write two equations, one for the negative version and one for the positive version, right? Those are my two cases there. If I have inequalities, right, I have the absolute value where it's less than n. Again, I would do the same thing, write two inequalities, one with the positive case and one with the negative case, remembering to flip the inequality symbol. Or if it's an absolute value of a greater than of n, right, then I would do the two cases, right? One where I write it just like normal with a positive case, x is greater than n. And then I would also do the negative case where x would be less than negative n, right? Remember, when you do the negative case, you have to flip the inequality symbol. So that is how you're going to approach these problems. Again, thank you guys for watching. Let me know if you have any questions.